the battery management is tip-top today. um, so, great welcome to you. Thanks for the synopsis. And I think that we could probably all learn a lot before we go out spending our precious rands to purchase stuff that might or might not work, and then we'll mess it up. And but with your guidance, I believe, Johan, we're definitely on the right road. Thanks a lot, and over to you.
It's a pleasure, and let's not jinx this evening. Let's hope it goes better than my previous attempt with a fiber network letting me down. Let me just start sharing the screen. Okay. And system audio, share. And okay, can everybody hear and see?
You can see the slide and
see the presentation. Okay, let's do it while it goes good. This thing started off mainly concentrating on lead acid batteries, and the usage and the management thereof. So being scientists, we always go and look at a bit in the history. When did batteries actually arise? So around about 1800, the first electrochemical cell, Alexander Volta, the reason why we're talking about volts, invented the copper zinc voltaic pile, and Napoleon made him a cap for the first practical battery. But he believed that the electromotive force, the volts, originated at a contact between two metals and not through a chemical reaction. Then in 1801, French scientist Nicolas Gaudrot observed in 1801 that wires that has been used for electrolysis experiments would themselves provide a small amount of secondary current after the main battery has been disconnected. So in this electrolysis experiment, you're sitting with a conductive liquid and you would actually charge it a little bit. So that was the basis for how a chargeable batteries works. And then in 1859, Gaston Plante's lead acid battery was the first battery that could be recharged by passing a reverse current through. Graphically, they look the same, look like this. Alessandro Volta with his copper and zinc electrodes with the electrolyte in between, and Gaston Plante with his liquid and his plates making the battery. The inner workings of a lead acid battery, when it's fully discharged, you're sitting with lead sulfate on both ends of the battery and a very weak solution of sulfuric acid. Once it's fully charged, all the sulfuric sulfur compounds goes into the liquid and creates a more concentrated sulfuric acid with pure lead on the negative side and lead oxide on the positively charged. And as you use the battery, it will move slowly back to the fully discharged state. Now there's three main types of lead acid battery. Your flooded battery, that is the one that we basically know the best. It's got a liquid medium in the cell and it discharges and charges more efficiently than about any other battery. But being a liquid, it can stratify. In other words, the density can change from the top of the pile down, or top of the vessel down to the bottom of the vessel. So you actually need something to stir this liquid medium up to keep the battery in a good working state. That's where the other two types, your absorbed glass matte batteries and your gel battery, where the matte prevents them. It's a mat that sits between the electrodes that keeps the electrolyte from moving and up and down in the battery and stop the stratification. And your gel battery just replaces the mat with a gel that keeps the ions in suspension. The disadvantage of that is it reduces the carrier mobility. So your gel battery is not good at supplying high surge currents. And that leads to the three basic types. Your starter battery got thin plates that relates to a large surface area. It's got a high current capacity, being able to pull a starter motor for a short while. Mainly your car batteries. Your deep cycle batteries, thick plates, relates to a lower surface area, but it's better at doing a low current drain over a long period. Falls in the general class of leisure batteries. And then your standby batteries, designed for low maintenance, and the alloys used allow the thing to sit on a float charge forever. And this is typically your gel cell batteries, and to some extent your AGM, the glass matte batteries. Now, specifications of your lead acid, the chemistry theoretically gives you about 2 volts for each, 1.8 volt when it's fully discharged and about 2.1 volt at full charge. And if you want to study the health of a battery, you measure an open circuit voltage. Now, this is very important, that the battery mustn't be working when you measure this voltage. 100% state of charge on a 12-volt battery, around about 12.73 volts, 50% around about 12.1 volts, 40%, and this green area is generally the area that you want to keep the battery in. So the moment you measure a battery and it gives its nominal voltage exactly, 6 volt for a 6 volt battery, 12 volt for a 12 volt, 24 or 48 volt, you have a problem. This thing is now very close to the 50% discharge limit. Another way of measuring the state of charge is by measuring the specific gravity of the cell, which only works on your liquid cells. Now, there can be great confusion between state of charge and state of discharge. So a 70% state of charge, meaning there's a 30% state of discharge. You've used 30% of the capacity of the battery. But we'll get to more detail about this a bit later on. But now, to understand what all these figures mean. 100 amp hour, does it mean 100 amps for 1 hour? No, it is very, very wrong. The design spec rated at amp hours is the capability to supply a current for 20 hours. So a 100 amp hour battery, the design specification is 5 amps for 20 hours. And our favorite 7 amp hour gel cell batteries in your alarms and in your gate motors and things, it is designed at 7 amp hours. That relates to 0.35 of an amp for 20 hours. And there you can already see a problem. That's why people have a lot of problems with these batteries on gate motors, because a gate motor doesn't draw a third of an amp. When that thing starts moving, it draws in the region of 5 to 10 amps. So we'll get to what effect. That's why the 7 amp hour batteries in that instance give you more trouble than what it is worth. So general rules: regular low current usage kills the cells. So don't draw piddly little currents from your cells. Batteries like to work. So your charge and discharge must be at least 10% above the design specs. That doesn't mean that your 100 amp hour must now only work at 5.5 volts. You can safely draw anything 5 to 10 times the design current from a battery, and it will not hurt it because the battery likes to work. When it works, you on a flooded battery, you get the electrolyte being heated up, and the convection currents in there stop it from stratifying. So this lead-acid battery likes to work, but you must avoid the regular below 50% discharge. So occasionally, sort of okay, but not on a regular basis. And then very important, you do not store a lead-acid battery in a discharge state. Always charge it full before you put it in storage, and check your voltage at least once monthly in storage, and charge it if it needs charge. You can keep a lead-acid battery on float charge. Now, 12 volts, your gel batteries, float voltage is about 13.05. Your flooded battery 13.4, and your AGM 13.6 volts. That is at 25 degrees centigrade. And you must compensate per cell of approximately minus 3.9 millivolt cell per degree centigrade. So a 12 volt 6 cell battery at 20 degrees centigrade, that's a minus 5 degree change in temperature from 25. So minus 3.9 times the 6 cells times minus 5 give you a plus 117 millivolt. So a flooded battery at 20 degrees, you must float it at 13.52 instead of 13.4. So as it gets colder, you must up your float charge. As it gets hotter, you drop your float charge. So the 25 degrees is a reasonable average that we can use here in South Africa. So that only time when you have a gel battery, make sure that the float voltage is lower than the other two. I like to float lead-acid batteries at 13.4. So,
hi, if I can just interrupt, maybe I'm asking a really silly question, but what are these different batteries? Can you just give us a practical example? What is a, you're mentioning these different batteries.
You know, the little battery that's in your electric gate or in your alarm. Small little 7 amp hour gel battery. They all fall in the class of lead acid batteries. And then you can go to a battery center and you can buy a starter battery for your car, or you can buy, it is printed on the battery. And especially your AGM, your glass matte batteries, they look the same as your starter battery. And you get your deep cycle batteries, and that's where your AGM battery is fall into the class of deep cycle batteries. Does it make a little bit more sense now?
No, not at all. I mean, just a practical example. The battery in my car is a one kind of battery. The battery that I'm in a torch is another one.
The battery in your car is a flooded cell battery. It's got liquid electrolyte in there. Even though it says it's a, most of the modern ones says it's a maintenance-free battery, there's a glass thing that you can look in that will give you a state of indicator that tells you that this thing needs top up. And most of them do have plugs that you can open and top it up with distilled water. So your classic car battery is a battery that you can top up with water, and your batteries that is in your UPSs and things like that is ones that is sealed, that you don't stuff around inside them. And a battery that's in your torch is a totally different chemistry. Does it make a little bit more sense now?
It's as clear as mud.
Yes. But anyway, hopefully, once we get through there. So now you decide you want to use a battery for something. So now you know what you want to use it for. Now you get to know the battery. You measure the voltage of the battery. But before you measure the voltage, let the battery rest before taking your reading. Meaning disconnect it from everything for at least 1 or 2 hours. Say you've just charged this battery because you want to test it now. Do not measure the voltage right away after you've removed the charger, because it will always overread the charge voltage. The density of the ions in the electrolyte concentrates next to the plates, so it overreads the state of charge immediately after you've removed it from the charger. Ideally, the rest voltage only stabilizes after 6 hours and definitely stable after 24 hours. Now, I don't know about you, but none of us will wait 6 hours and definitely not 24 hours to test the battery. I call it nicely, it's not always practical to wait that long. Now you can, after an hour, your battery will read a maximum of 10% too high. After 6 hours, about 2%, and then slowly settles the last percent. Now that you know about that, you can use some simple logic. So you've charged your battery, you've taken the charger off. An hour later, you measure that it has an 80% charge in the battery, and that you infer by looking at your state of charge. So your 12-volt battery will measure 12.5 volts. If it is a 12-volt lead acid battery. Now, you know that at an hour, it'll be about 10% too high. So then you are definitely sure that the battery will at least be 70% full after the full rest period. So you're starting off with a battery that's got a 70% state of charge. So now you know the beginning state of your battery. Now you, as I just measure, before you use it, it's probably been used, has not been used for a while, but you could estimate what your state of charge is, and then you use it for a session. Let it rest again for a few hours, or at least an hour. When you measure the voltage after the battery has been discharging for a while, it will underread the same as what it overreads after a charge. So if you remove the load, it will immediately measure a little bit too low. And then after an hour, you know it will be about 10% too low. The reason why you want to do it, you want to see how much charge you have used over a typical session. And then that will enable you to work out how long a full charge will last under your normal usage, the usage that you intend this battery for. But remember, do not drop. If you find that when you use the battery in your typical usage, it will go below 50% state of charge, it is not good. You need either a bigger battery or you need to use less load on it. But as a recap, state of charge, 12-volt battery bank, and then typically it differs a little bit whether you've got a sealed or flooded lead acid battery or a gel battery or the AGM battery. We'll see the AGM battery about 50% generally reads, but they're all very, very close. The sealed battery or your flooded battery changes actually quite a lot between full and 12.2. But you will quickly get used to, if you just get this ballpark figures by looking at typically what battery you have. And most of this is actually printed on the outside of some of the batteries. So, but now you start using the battery. And you discharge it, meaning depth of discharge. You use 100% of the battery every time you use it. Your starter type batteries, you will end up with 12 to 15 cycles that you can use it, recharge, use and recharge, after which your battery is gestoofd. Deep cycle battery, 150 to 200 cycles. If you only drop it down to 50%, the starter battery goes to from 100 to 120 cycles. That doesn't sound right. Because you drop it down to 70%, meaning 30% depth, it only gives you 100 to 130 to 150 cycles. But your car battery, you don't start your car battery only 150 times and then the battery is flat. It lasts for quite a number of years and many more starting cycles. That is why this type of batteries like to work. Because every time you start it, it pulls a massive amount of current. When the engine fires up, it pushes a massive amount of current back into the battery. It stops that electrolyte from stratifying and killing the battery. When you drive around, the vibration helps spread. So your starter battery is a battery that likes to work. But it is not good for the type of things that we want to do. For deep cycle battery, 100% discharge, 150 to 200 cycles. Not good. 50%, 400 to 500 cycles. But if you only discharge it to 70%, meaning depth of discharge, 30%, you get 1,000 and more cycles out of it. And that is the window that you try and use your batteries for backup purpose and emergency power. Try and keep it in this window. Like starter batteries for your cars, they're the cheapest, but they're not good. Deep cycle battery is designed to give you this lower current draws for a long period of time. But anyway, after this, for us in the field, when we want to go out, I've actually built what I think is my ideal battery box. Batteries underneath here. Got meters for the voltages, enough connectors. It's got a step down regulator that I can get a voltage below 12 volt. Got a booster regulator that I can get voltages above 12 volt and 5 volt for USB power, and then obviously all the 12-volt connectors. And this has been working for many years now very well. Because there's enough batteries that in my typical usage, it will hardly ever drop down to 70% or 60%. Use the batteries properly and it will last. And then we come to a little bit about your lithium batteries. And you will find a myriad of them. Lithium ion, lipo, li-Ti, LiFePO, and this LiFePO batteries, people claim that they are drop-in replacements for your 12-volt lead-acid battery. I can't say whether it's true or whether not. I've looked at a few advertisements of these batteries, and somewhere in some of them, it puts a little note that you must use a charger that is capable of charging lithium batteries. So I do not know what this LiFePO batteries, this is the new fashion it seems, will do with a normal 12-volt lead-acid battery charger. Because you know that the lead-acid battery has got a nominal voltage around 2 volt. Your lithium-ion batteries has got a nominal voltage each cell of 2.4 to 3.7 volts. So they're not directly replaceable with each other. Now your LiTi, your lithium titanate or titanate titanium oxide battery, is a rechargeable that's the fastest one to charge than other, but there's a disadvantage of having a much lower energy density. So it has 2.4 volts per cell, where your standard lithium battery is 3.7 volts per cell. Your LiPo lithium polar battery, or more lithium ion polar battery, lithium ion polymer battery, that uses a polymer electrolyte instead of a liquid electrolyte. So the titanium oxide one, still liquid. A polymer inside, it's a plastic, if you want to go simple, electrolyte. And then your classic lithium ion, which again, there's a myriad of them. It uses the reversible reduction of lithium ions to store energy. And that's your predominant battery used in portable consumer electronics and electric vehicles. Now the question I had about what you get, some of this torches and radios and things that has this rechargeable battery in there. And that is most of the time around blue cell lithium ion battery. And there are many more types. You will read and read, and they come up with a new name every second day, it seems. Better than lead acid, but needs special care when in use. So what happens when you charge it, the positive lithium ions move through the electrolyte to your negative plate, your cathode. And when you discharge the battery, they move back. So the flow of ions is what creates your charge and creates your current that makes the battery work. But this needs special care when in use. We will get around to now. So here's now a clever, and where I got this from was people are pushing this lithium titanate batteries, meaning they have got the most lifetime, the most usable power, the most performance, also the most cost, the most energy density, but your lithium iron phosphate is very close to that. Cost is about half of the pure lithium ion battery. Performance is close to that. Usable power, how much you can draw this thing down, is very close. Lifetime, but the lifetime of your battery gets more determined by how you use it. And then safety, everybody says that your iron phosphate is safer, but they and the lithium cells are definitely not very safe to use. If you misuse it, it is going to surprise you in a big way. Your gel batteries is very close in performance, price, etc. than your standard lead acid batteries. Cheap, doesn't have a long lifetime, but we'll get around to it, but that they actually don't have that bad a lifetime if you use it correctly. So in our case, we'll mainly look at this thing, cost. And this doesn't include the LiFePO batteries, the iron phosphate batteries, and they fall somewhere around just outside the envelope of your lead acid batteries. So now the big problem with lithium batteries, if you do not use them properly or you don't use the proper charging equipment with them, and you've heard of these things exploding. Now, I found a fairly humorous video about why do they explode. Let's hope that my video does work.
So that's a lithium-ion cell, and I'm going to show you what would be the consequence if I overcharge the cell. Bulging actually, now you can see that. Can you see now?
Yes, the cell is visibly bulging. I can see it.
Yeah, the cell is visibly bulging.
Yes, because according to our checks, we're getting very close to overcharging it.
Yeah. Now it's time for us to move back. Move back.
So I see a bit of smoke. Oh my goodness.
Can you come? Yeah.
Imagine this multiplied many, many times when it's all in a pack.
When you pass a current, and you notice about a 10-degree rise in temperature during the whole charging process from an unreliable source, while the temperature does not rise beyond 3 degrees centigrade for this particular cell obtained from a reliable battery manufacturer.
Okay, so what's the worst that can happen?
Every time cell warms up, you are evaporating the liquid electrolyte into gas, and the local pressure build up, and it leads to so-called,
An explosion.
explosion. The other possible cause could be inappropriate charger. That's very, very important. You must get the same charger which is meant for this particular pack, preferably from the same supplier.
Fortunate. The fact is that your lithium batteries do have this problem that if you mistreat them, you're sitting on a bomb. They doesn't matter what the marketing blurb says. I'm I feel very unsafe with these batteries at the moment, especially now that they're flooding in at zillions because we need them. And the marketers doesn't help. So let's now go to some more practical things. How much do I need? And that is where you must be aware of the marketing numbers, because these people will list the spec and make the thing sound much more fantastic than what it actually is. So they will sell you a 7,000 milliamp hour battery, which is actually your 7 amp hour standard gate motor battery. And one that I stumbled across a few days ago, a 50,000 mega amp hour, which should actually be a milliamp hour, which was a 50 amp hour battery. And then something that you see, sometimes they rate a generator, especially in VA, or sometimes even inverters and things, versus watts. Now your VA is an instantaneous direct current power that is produced. Now your AC current goes to AC voltage goes to a maximum, goes through zero, goes through maximum minus, goes through zero. That peak of your sine wave, that times the current that the load will draw is your VA rating. But because we're using alternating current, the watts that whatever you buy, and there the people can fight with me, that's approximately 0.6 VA. So if you've got a 10 kVA generator, it is only a 6,000 watt generator. So that value, that VA value, is you only get about half, just over half of what it is writing, if it is written there. So remember this, if you buy a generator and suddenly you connect it to your geyser and it sounds like it is running at full power where it shouldn't, look at the VA rating and then work it back to watts, and then you will see that maybe this 6,000 VA generator, when you drive a 3,000 watt geyser from it, you're running it close to maximum. In which case, if you use a generator, do not run it continuously above 80% of its rating. So this is where they catch you, because the VA value sounds much better than the actual watt that you get out of whatever device it is. Inverters, generators, anything. And you remember that your 100 amp hour battery, the design spec over 20 hours is a 5 amp current. You're packing much more watts into the
Johan, we
same
lost you
space.
there for a moment. Sorry, Johan. We lost you there for a
Yes.
moment and your slides have gone off. Is that right? Your
That's
screen
strange.
went dead and now it's not sharing anymore. We can see your video of you now, but not your screen.
Okay, okay, let me just. Okay, let me just get to the meeting screen. There it is. Share screen. I don't need the system audio. Okay, don't know why it. Okay, you should be seeing the.
Yeah, we can see the slide again now.
Okay, the previous slide was. Okay, did you get the whole story that much? Important that one thing of course, the rating that they give of A versus what. That thing is not much more than 0.6 of the rating. So your marketing numbers and your design 5 amps for 20 hours. Now energy density of acid-type batteries versus your lithium ion much more into the same volume. Your specific energy watt-hours per kilogram. So your lithium ion batteries for the same watt-hours that it can supply is much lighter. Flood maintenance and no for this higher density, specific energy, you pay a price from 10 times to 6 times. Between 6 and 10 times the cost between a lead acid battery and a lithium ion type battery. And now your cycle life is 1,900 and 1,000. Suddenly the acid batteries doesn't look so bad. Even though it costs between 6 and 10 times more, you need to double the number of cycles. And you can discharge it to 80% charge window, use 80% of the rated capacity of that. Lead acid is used to 50%. And depending on how much you draw it. If you draw it at a design spec 5 amps, you get 100% of the capacity available. Actually 50% the battery like a 100 amp hour battery. If you draw it at the 4-hour rate, otherwise using up your 100 hours in 4 hours, you draw 5 amps of this battery, meaning 5 times more. Then efficiency 80%. So your 100 hour battery an 80 amp hour battery. If you of a 6 amp hour battery, it's a big batteries. It changes the efficiency as the more current you draw out of your battery. Where your lithium battery is fat. The moment you draw, it starts dropping as well. So, but if you count all of this in efficiency, that you'll find that there's, at the end of the day, very little difference whether you have lithium batteries or whether you have lead acid, provided you use both of them properly. So if you use the lithium-ion batteries, make sure that you use the proper charger, like treat it like it should be treated, because you're sitting on a bomb. And now for a more practical example of this, and when you decide you need power backup, you must now get to know your usage pattern. Use what you need on and for how long. So you first decide what you want to use for. So I've decided my laptop, which draws 50 watt, screen 20 watt, LED lighting, my TV watt, and the internet working also keep myself busy. And internet that draws 20 watts so that I can talk to Hermanus at the same time. So total I need to draw from my backups 150 watts for 4 hours. That is 1 hour's capacity. So that is the capacity that I would like to have available in my batteries. Now, a typical inverter, which is similar to one that I'm using, 1 kilowatt amp hour 12-volt battery. And my inverter is a pure sine wave inverter. You get cheaper ones that is a modified sine wave. For your sensitive electronics, pay the extra money and get a pure sine wave inverter. You will not be sorry, because some of the forms on typical modified sine wave, hybrid, they call it many names, but anyway, it's basically of this inverter that. Now the first check that you do, it can supply 1 kilowatt, so it can easily drive 150 watt load. Second check, your 150 watt load will, because the battery must eventually supply this 150 watts. 150 divided by 12, I'll be drawing 0.5 amps from that 12 battery. Now you remember the C20, the diesel spec is 5 amps. I'm drawing just over double from that. If I draw, if we look at the previous slide, if I drew 5 hours of that, the battery will act like an 80 amp hour. Now, I'll be sitting very close to the 100%, definitely above 90% if I do double of that, because 5 hours drops down to 80%. So you can estimate close to 100%. So supplying will probably have 95 amp hours available. So do not base on the full capacity of your battery unless you have lithium batteries where the efficiency will be much higher. So but the principle is the same. You look at what actual battery you have available when you put the desired load from it. And I have 95 hours available in my battery. So battery times 95 hours, so I have 1,140 hours capacity available in the battery. If I used it at 100%, I would have had 100 watt hours available capacity in the battery. because I'm drawing more than the desired, the number of watt hours has actually decreased a little bit. And remember the safety factor, I do not want to drop my batteries below 1001, below 50%. So I have usable watt hours in my battery of 170 watt hours. We need 600 watt hours to cover the total load for 4 hours. So there's a little bit of a problem. I don't know if the full 150 of the time for 4 hours. Most electronic equipment, they draw more, they draw less, and there's 150 watt on the power supply of the thing, so it would probably draw a little bit less. So even though my marginal practical proven me that it is possible with inverter 1 kilowatt amp hour 12 volt battery to do what I have to do if I go 150 maximum for 4 hours. For 2 hours, easy, no problem. But now comes the other problem. After the 2-hour session, that the power is out, or after you need to replace the 600 watt hours in the battery. Otherwise, next time you are in trouble. Say you're using a 12 volt 10 amp charger, that's 120 watts. You need 5 hours to replace. But either better charger or use less wattage. Fortunately, this inverter got a 30 amp charger, so it doesn't have a problem replacing the power. So you look at what you want to drive. You look at whether your inverter or generator can drive it. You look at how much capacity you have, and always work everything back to watt hours. And calculate watt hours, and then you compare the same measurement, everything, and then you can quickly see 150 watt hours for 600 watt hours I need. So that is the thought process. So even though I did get a better charger, and I'm working, and I'm not for 4 hours below the 50% limit. So this is about the talk. Now, theoretically, the ideal system, now you will not find it unless you build it up. We will feed power from XCOM, or from solar array, or from generator, all going into one controller. This power supply must be able to supply the load and keep your battery topped up. And either of them needs to be, when they work, doesn't have a problem of driving solar array, only uses solar. You'll have to decide what you want to use it for. Here again, also what you want to use it for. In the case of split the DB board and the generator and the inverter supply half of the DB board. I'm not using it on my geyser and my stove, and the inverter only supplies a few plugs in the house where I plug in my thing that must stay up all the time. The reason why this is the perfect one, the power supply will keep the battery bank topped up. The battery bank will drive the inverter, which will drive your load. And either of these or any of these drop out, the load would not even know because the inverter is continuously off. So most inverters, even though they say it's an inverter UPS, the switch over is not seamless. It drops and then it clicks in and everything works. So sensitive loads suffer if you use it as a UPS. So there's all small practical things that you need to get. Because the same ESCOM drives directly to your load. If it comes back, it can damage your inverter. It doesn't switch smoothly, it can damage your load. So be careful. If you have sensitive equipment running off your inverter, put a line interactive UPS before it. So it's an extra cost, but it will protect your sensitive equipment from the dip that the inverter causes when it switches over. And I hope that everybody is still here and that I haven't put anybody to sleep. Now it is time for questions and hopefully answers.
Johan, thanks very much. I learned a hell of a lot there. Yeah, about all the what my experience was makes much more sense now. I had 2 lead acid batteries with a 1.2 kilowatt inverter, and they would last me the 2 hours. They wouldn't make the 4 hours. They might make 3 hours, but they hardly ever. I needed to go to 4 batteries, and that's 105 amp hour deep cycle batteries. I had 4 of them, and then I didn't have an automated system. I had to go and swap cables around every time you had load shedding, and I got so sick of that.
Yeah.
I got a Victron inverter and a lithium battery, all operate seamlessly, automatically now. It's just fantastic. With a lot of money, it was worth it.
Yeah, no. Like I said, in this case, what you want to do, you must balance it with how deep your pockets are.
Yeah, I'm very happy at the moment. Yeah, so it switches over in 20 milliseconds. It's literally seamless, except occasionally you seem to get a glitch and it takes a second or two to switch over. If I'm working on the computer goes off and then comes back on again a second later. But normally it's normally.
No, mine also says the switch over time is in the milliseconds, but because I'm driving my 3D printers with it as well, to give me time to go out and start the generator if I'm in the middle of a print. The line interactive UPS actually warns me that there was a dip now.
Okay.
So some of these things. Also, what I discovered, this thing has got this pretty display. When it runs off ESCOM, it says the input voltage is anything from 225 to 230 volts and output 220. So I thought this thing was cleaning the power from ESCOM. Make no mistake, it's called a digital filter. It gives a reading of 220 volts, but the ESCOM power gets passed straight through, no cleaning at all. When it goes over into inverter mode, then it supplies the actual 220 volts.
Yeah, okay. Yeah, I noticed because you've got this app where you can monitor everything. When ESCOM comes back on, it's down to 211, 212 volts, and the inverter won't start charging until it comes up to 217. And about an hour or two later, then the ESCOM runs it at 224, 226. It never goes up to 230. Anyway, that's my experiences.
Yeah, no, like I said, depending like how sensitive your equipment is, that also depends. But like I say, once you've done all the calculations and you've determined amount of batteries that you need for the use that you have of it, or that you need from it. Then you can compare the cost between lithium and lead acid, and you'll find that the lead acid is actually a viable option, provided you don't use much more than 30% out of the battery every time. Then you get nearly the same life cycle as what you get out of a lithium battery, but you must nurse it.
Okay, anybody else got questions? Chris? Any questions?
Chris will attack me on Saturday on this.
How much would it cost for you to build one of the systems that you have to drive basically a computer, maybe a TV, and something else smaller?
I'm not being paid to advertise, but at
Well,
the
now's your
moment,
chance. Yeah.
no. I'm not going. You can go and buy this thing. Let me just quickly go to a. Because I've seen that builders or us have. Let me just get the price. Where is this? Inverter. Electrical. And okay, do you mind if I share a screen quickly?
Go ahead.
Share screen. Okay, let's do it in Microsoft Edge tab. Just like it's very clever, this one. This is exactly the model that I have. And they're now 8,500 Rand. And the builder's warehouse just around the corner from me, there's 9 in stock of them.
So has that got its own battery, or do you need separate batteries?
Battery, everything is built in.
Is it a
On a
lithium
little
battery built in?
tutorial. No, that's one of this AGM batteries.
Okay.
No, it's a lead acid battery. Otherwise, it's not going to cost. A similar one, I can go to some of them, but here they sort of give you 150 watts, 4 hours. So their specs, and this is a pure sine wave inverter, the specs is actually quite accurate. A few things I don't like about it. If you look at the back of the damn thing, and this, you can't get this picture bigger, but anyway, where you plug in the AC power is just under one of your other plugs. So the two wires always fight with each other, but that's just a stupid design on their top. But it's got a 12 volt DC 100 amp hour deep cycle valve regulated lead acid gel battery. So the battery is designed for this type of work. But I've been using this one now for quite a while, and for the purpose that I use it, it works very well. If we now go and look at other inverters, And this EcoFlow thing, even though it says it can supply 1,800 watts, it's got about the same. They've got lithium batteries inside, and overall it will do about the same work. You're looking at 27,000 Rand.
Yeah.
So that's the difference between 8,500 and 27,000 Rand.
Oh, then I can get 3. So.
You understand?
No.
And
And you
this,
say you've got to look after, you can't mistreat a lithium battery. How do you mistreat a battery?
well,
Overcharge it. So you must have the
well,
right charger.
this thing,
What-
because it's
what is
26,000 Rand, I
Hmm.
trust that they have a proper charger inside there. If you start building your own system, that's when you must look at the quality of your charging, the specs in detail.
What,
Then they've got,
what technical qualities make it a good charger or a bad charger?
well, the specifications of the thing. There's some name brands around that if you start looking at your friend Google, you will quickly hear or see reviews and things like that. What Derek has, your Victron, seems to be a very good make. They also have very good prices, as Derek would attest to. This same make also has with a 2,000 watt inverter, then it's 18,000 Rand, and then it's got 2 batteries built in. I know what this one weighs. I don't want to know what this one weighs. It must be horribly flippant heavy.
Johan, they've just got a question on the chat from Alka. He asks, what do you typically use that RCT Megapower 1000 for? In other words, what have you got running when you've got that on?
Well, what I'm running now, my extra screen, my laptop, my fiber box, my router, Wi-Fi router, a switch, which is the network port at the back of the router goes to a switch which supplies wired Ethernet to all my machines. It goes over to my wife's workshop where I have, she has an embroidery machine and another computer and 2 printers. We're not having all of them at the same time, but a typical day when there's load shedding, she now wants to busy embroidering something. So embroiderer can work with all my things at the same time. The inkjet printers, they draw so little. I can print on there. I can scan documents. So normal usage, and then there's 2 or 3 of this little reading lamps spread around that runs of this thing, so that we always have light. And then in the evening, whenever somebody wants to watch TV, the TV is also on it. If I have everything at the same time on, but you can't use everything at the same time, I can either work on my computer, or she can embroider, or we can print, or we can watch TV. So as long as you keep the total power drain out of it, below about 150 watts. And that's looking at the specs on the power supply of the things. So if it says 50 watts, this thing normally runs at about 30 watts. So I'm taking that chance that the power supply is overrated. But round about 150 watts, and you cool for 2 hours definitely.
And then
4
Arco
hours.
wants to know, sorry, Johan, Arco wants to know what device have you got between the inverter and your components to protect against power surges and so on.
Because most of these things have your little brick, like my computer monitor, they have switch mode power supplies. The switch mode power supply does have a bit of carryover, which filters that out, because you can put any junk into these little brick power supplies, anything from 90 to 230 volts. That's how they rate it. My sensitive equipment that I don't want to stop, like the 3D printers. Now, the 3D printers I only use on the inverter if I really need to. That usually happens if I've got a 7-hour print, but there's only 6 hours available. It can drive because the printers draw around about 200 watts. So I plan that it can carry the printers before I can go, and I have to go and start the battery. I start the generator. I'm actually thinking of getting an extra battery. These ones do have a port at the back for an extra battery. There's the 2 ports. One is a solar port, so you can actually put solar panels into it, and one is an extra battery connector. So you can upgrade your battery capacity easily with another 12-volt 100 amp hour battery. But between this and the printers, I've got a serious line interactive UPS that cleans the line power continuously. So
Do you have to rewire anything, or does it go into the
no, this is all temporary. This thing plugs into a plug in the house. Behind it is one of those multi-plug strips, which I've just screwed into the wall, and then I've got extension leads, but I've put the extension leads neatly. The one to the wife's workshop went through the ceiling. The one into my little office here also out of the way. So the thing is permanently wired, but with extensions onto this UPS.
Thank you very much. Thanks very much.
You can, well, my generator is wired into the DB board where I've got a changeover switch. You can do the same with this inverter where each output will feed into a changeover switch in your DB board, but then you've got to be careful that you only supply the plugs that must be supplied. I've decided I only want to supply this and this and this and this. Ran extension leads to them and be done with it.
Thank you very much. Yes, thank you. Good.
If power goes off, okay, I have stopped sharing. Did I? If the power goes off for longer than 4 hours, like we had our bonus sessions before, then I have the option of going to start the generator. But since I've put this one in, I've only started the generator at special occasions when I have to do something and I must now use more power than what the inverter can supply.
And somebody asked on the question, Johan, can one run a refrigerator on such an inverter? My experience was with a 1.2 kilowatt pure sine wave inverter, it wasn't able to run the fridge. The problem is when the fridge starts up, it has a sort of a current surge initially to get going, and that was just too much. It would trip the inverter.
No, that is definitely not on. That's where your VA rating comes in. Because your fridge will, you need at least 2.5 kilowatts to run a fridge reliably. But in actual fact, I've run two fridges and a deep freeze off a 2.5 kilowatt generator. And the generator, well, it was a pure sine wave generator, damn expensive little thing, but it managed that. But also again, now you must look, your fridge draws nominally, say, 500 watts. However much it is, if you want to run it for 2 hours, you need 1,000 watt hours. Your 12 volt 100 amp hour battery has maximum 1,200 amp hour, 1,200 watt hours capacity in it. So you will run it for
50%. So actually, it's actually got 50% of that available.
Yes, so you after an hour, your battery will drop to the danger, into the danger zone. So running fridges and things like that off inverter, like you can get your 5 kilowatt inverters that will run a fridge quite happily. But for how long? That is determined by your battery capacity. And if you look at your battery capacity in terms of lead acid and lithium in that case, where you need a massive amount of batteries, then you'll have to do some serious sums. And I haven't done the sums, which one will work out the most cost effective. But lead acid batteries has the limit that you do not want to drop them below 50%. Lithium, you do not want to drop them really below 80% or 20% remaining. So, and then how long do you want to keep it on? So,
can I just mention again, in my experience, my problem with the lead acid, even though they're deep cycle batteries, they just took too long to charge up to full charge. And with if you try to cover 3 load sheddings in a day, you weren't able to charge them up to 100% again. Whereas with the lithium that I've got now, the day after I got it in December, we had a load shedding from 10 till midnight, and then the substation which supplies the overstrand area tripped. They only fixed that 12 hours later, and when they fixed that, then the substation for our block of houses tripped, and they fixed that 4 hours later. So we went 18 straight hours without Eskom power, and the lithium battery ran down to 25% in that period. I switched nothing off. My fridges, everything was running. I switched nothing off. When the power came back on, in 40 minutes, it was charged back up to 100%. It's just a no-brainer to me. If you've got the money, it's just the best option to have the lithium. It is a lot more expensive, but it just works so much better.
Yeah, but like I say, if you don't mind to give the people an idea what such a thing would cost, because like I said, that's close to the ideal.
Yeah, okay. But, I got a Victron 5 kilowatt inverter and a 5 kilowatt battery. I forget. I think it's a Freedom 1 battery, which is fairly good. It's got a 5-year guaranteed to supply 100% of its capacity. And after that, it starts dropping off for years after that. And that was, I think it was about 65,000. And then with changing the wiring, changing the DB board, putting in different changeover switches to cater for my generator and inverter, I've got 2 changeover switches. It all came to nearly 90,000 Rand.
Yeah,
But
no,
now I run everything with no hassle except for my geyser, and I've got a solar geyser, so I don't really need it for that anyway. Of course, I don't use the oven, electric oven. I've got a gas stove, so I'm relatively independent with it now. But it was a I had to bite the bullet.
No, look,
I just thought it was worth it.
No, if I can get to that, my pocket goes that deep, I'll definitely go into that direction. And
the other option, if you don't want to spend that cash, then a 1 or 2 kilowatt inverter, and I would say 2 and preferably 4 deep cycle batteries. And if you have 3 load sheddings in a day, don't use it in each one. Just use it in the ones that you really want to watch rugby on TV, or if you want to watch the stock
like I said,
or whatever.
That's why I said in one of the slides, you must choose what you want and when and for how long.
Yeah.
But like I say, it's now when you now go and buy an electric car, you'll have to plan your trips better than what you would now do with your normal car. With your normal car, every little town has got a garage that you can fill up. With your electric vehicle, you'll have to now find out when you go on a trip, you've got to plan better. Same with this situation that we're in. We've just got to plan better.
Yeah. So, yeah, I think that was very, very useful. I don't know what the other, anybody else with more questions? David and Elaine.
I have one. Yeah, Derek Hill, thank you. I've got one question, please, Johan. The cost of lithium-ion batteries at the moment is dependent upon us using second-use batteries. They all come out of all the static and domestic batteries, I understand, come off traction battery applications, and therefore they're much cheaper. And I'm concerned that as the usage of lithium batteries goes higher, we won't have the source of those extraction batteries anymore, and therefore the price will almost double. Do you have any views on that, Johan?
I don't know. Like I said, I'm sitting firmly on the fence. I appreciate the lithium technology and that not. And as most of the electronic things, we're getting them from China. How well you can trust the Chinese and what they write on the things, I don't know. So,
but am I right in saying all of our lithium batteries in domestic applications are second-use batteries? They've been used before elsewhere.
I don't know. That I can't comment on at all.
Okay, all right, thank you. Just one other very interesting observation with the Eskom load shedding that we've experienced, and this is just for information. Previously, as the load increased on Eskom, the cycles per second would decrease and all your electric clocks would run a touch slower. Now, since we've had load, I noticed that the cycles are above 50 cycles per second and the clocks are now running faster. I just found that very interesting.
No, I've seen, because this line interactive UPS that I have here to protect the 3D printers, it shows the the frequency, and it does fluctuate. I rarely seen it below 50, but I've seen 51 a few times. But so far, Eskom power seems to be fairly stable when it runs, if it runs.
I think on the
Can you fix that?
Sorry? No, I haven't
Okay.
I haven't monitored with a frequency analyzer or oscilloscope or anything like that. But if we're lucky, we should see my lights come on in the next few minutes, because my backup system has carried us all the way through from 6 o'clock to now.
Okay, we've got.
Yeah, thanks and well done, Johan, with your backup system. It's lasted you all through this presentation. Thank you very much.
But I've not designed it. I've looked for something at a price that I can, well, that didn't give me too much pain, and it's doing what it's supposed to be doing. And I'm thinking of adding another battery to it, and then it will serve my purposes for even longer. Because if the power is off, it's off. I'm not going to start.
All right, maybe
disadvantage.
Go ahead, sorry.
The disadvantage of investing in this thing that is a lead acid based system, I can't go and buy a lithium battery and put it there.
Yeah, you need all compatible equipment, yeah.
Yes. On paper, this LifePo lithium
Iron phosphate.
Iron phosphate, they say it's a drop in the replacement, but I've seen a few times that it warns on the spec sheets, use a lithium compatible. So it looks like it's a drop in the replacement for lithium batteries, not lead acid batteries.
Yeah, just a comment on the frequency, the 50 hertz that Eskom runs at. I think they have to control that very accurately to keep all their different systems in phase with each other. Otherwise, they have major with power stations exploding and so on. Like that new one, but that blew its roof off because they lit up the hydrogen gas that was cooling it. But I mean, those sort of things can happen. They have to very carefully control phases so that they're all in phase with each other. And part of that is keeping your frequency stable.
Yeah, but the frequency, Derek, does drop down to 48, and that's the really danger zone. And it can go up a little bit above 50. And I've noticed that it has been fluctuating up and down. And certainly major users normally contributed before we had load shedding to offering to shed their load once Eskom, and they had 50, 49, 50, 49.5, 49, 48.5, and then you'd have to switch on. So it does vary, and it does tends to slow the generators down, if you like. So yeah, it's got to be controlled very carefully, but it fluctuates between probably 48 and 51.5.
Well, we can check now what will happen when Eskom comes back. It should be in the next minute or two. My inverter says it's 49.8 hertz that the inverter is running at. So if you look behind me, there's a little screen that's lit up. That's the UPS for the printers. So there I can see
Mine says it's running, but it's been on since 4 o'clock, I think. So the Eskom has been in the middle of its full on cycle now, and it's at 50.3 hertz at the moment. 50.1, sorry. I must actually have a look at that and see just after it comes on and so on what the difference is. There's now it's
Yeah,
running at 49.9, so it does fluctuate. So it's just been at
Well,
51.1, 50.1, and then it dropped to 49.9, and now it's back
well,
up.
I say 49 point, and here the power comes on, and the inverter has kicked off, and it's back to 49.8. It fluctuated a bit at 49.9. So it and Eskom sort of well, like I say, that is how much I believe the screen on this UPS, even though it was expensive. This thing is programmed by some Chinese somewhere. This is now not measured with professional equipment, but it is like 49.8, 49.9. So
I think time is marching on, Johan. Has anybody else got any more questions they want to get in before we wind up? Peter Harvey, did you find it useful?
Sorry, say again.
Just asking, did you find the talk useful?
Did I find a what?
Did you find the talk useful to your needs?
Oh, yeah. I just think there's an awful lot of homework still to do. And when we get the recording of this, it's going to take, I don't know, we've been at this now for an hour and a half, but I think it's going to take 3 hours going through the homework to work out exactly what we need for our particular use.
I'm online, well, the whole day, Peter, and I think most of the guys in Hannes has my email address. You're most welcome. And even if you want to have a quick video call, no problem.
That's very kind of you, Johan. Thank you.
Well,
So
I have to
we all
do
appreciate
something.
that.
No, I'm working from home, so any reason to take a break is a good reason. I don't have to do office work 100% of the time.
Thank you very much, Johan. Very informative again.
Ja, dankie Ab. Groete daar aan die Kaap.
Tot weer, baie dankie.
Anyway.
All right, everybody else, before we wind up.
Thanks very much. Yeah.
It's a pleasure, and I hope that we have the same luck on the 13th when...
I was going to say, just about to say, we're going to see you in 2 weeks' time again. So let's hope it works out well this next time as well.
Oh, I would hope so too.
Yeah.
But anyway, it was enjoyable. But if anybody has any specific questions, I'm looking through the text messages here, and I think we've answered most, I think. But anyway, if anybody needs or wants to ask specific questions, most welcome.
Okay, I wish I'd heard this talk when I still had my lead acid batteries, deep cycle batteries, and I would have measured much more carefully what they could handle, because I think I overtaxed them a little bit, and that might have been part of my
well, I got caught, even though I'm supposed to know what I'm doing. I made this tracking table for my telescope, and I saw this beautiful Chinese pulse width modulator motor driver. I said, this is it. So I used that to control the speed of the motor, tested it at home on a battery, worked perfect. Took it to an observing evening, public evening nogal, with a fully charged battery, and then the thing was running away from me. It was running too fast. Then I realized this cheap Chinese thing wouldn't regulate the battery voltage coming in. It uses the pure voltage from the battery and chopped it up to get the right speed for the motor. So if the thing, I tested it with a half charge battery at say 12.6 volts. I went out there and running it now off 12.8 volts. That made quite a difference in the flippant speed going up.
So one learns.
Yeah. And in the long ago, like I said, I had this little 2 of the gel batteries that I used on one of my telescope mounts. So I decided, I don't have to charge them. Whenever I drive to where I'm going to use it, I made a cable, plug it into the cigarette lighter, onto the battery, charge the battery while I drive. This little gel battery doesn't like your car alternator at all, because now I'm charging it at like nearly 15 volts, where they're not supposed to go over about 13.8 volts. And this battery, these 2 brand new batteries didn't last a year. And they were fraught.
Yeah.
So lead acid batteries, treat them right and they will treat you right. Lithium is the same. The danger with lithium, if you don't treat it right, the lithium will really let you know in a spectacular way.